Welcome back to The Explainer. I am absolutely thrilled to have you here today. Look, we are going to tackle one of the most notoriously tricky yet absolutely critical topics in the Cambridge IGCSE Additional Mathematics syllabus, specifically code 0606. But frankly, this applies across the board, whether you're looking at 0580, 4024, or 4037. We're looking at exactly how to distinguish between maximum and minimum stationary points. But listen to me. We are not just going to crunch numbers today. No way. We are going to approach this entire concept like a master architect. I want you to think of your math exam answer as an architectural blueprint, where every single line of working, every paragraph, and every equation is a structural masterpiece. Seriously, think about it. When you build a house, you don't just throw a bunch of bricks at a plot of land and hope they magically stack up into a mansion, right? You need a highly systematic, evidence-based plan, and that is exactly what top-scoring, distinction-level candidates do when they face these really complex, multi-stage calculus problems. Now, I want you to consider the sheer weight of this quote, straight from a senior Cambridge examiner. Mastering how to distinguish between max and min points appears in every examination series. Stop and think about what that actually means for your prep. This isn't just a theoretical possibility that might maybe pop up on paper 1 or paper 2 if you're unlucky. This is a guaranteed foundational challenge. It's the load-bearing wall of your entire additional mathematics exam. If you don't know how to systematically prove whether a stationary point is a maximum or a minimum, whether you're deciding to use the first derivative test or the second derivative test, your entire structural blueprint just collapses. We are dealing with an absolute certainty here, which is kind of a gift, right? Because it means mastering this specific skill mathematically guarantees you marks in exam hall. So that brings us to the crucial point, the core question we have to ask ourselves. Why do so many students find multi-stage analysis and securing those method marks so incredibly hard? Well, we see two types of struggling students all the time. Let's call them Alex and Sam. Now, Alex is the type of student who just overloads the page with raw mathematical facts, dumping every formula they know, but completely lacks any logical analysis to tie it together. Then you have Sam. Sam just rushes, skips crucial steps, and completely misses the actual command word requirements in the prompt. Seeing these two approaches side by side with red pen marks all over them, it breaks my heart. Because this right here is exactly where we see the difference between an average, messy attempt and a true structural masterpiece. The examiner is actively looking for a connected, conceptual understanding, not just a frantic brain dump. Okay, so let's get our structural plans sorted. Here is our agenda for today's session. We're going to completely deconstruct the syllabus requirements into 3 very distinct phases. First up, we'll look at the core foundation. That's the underlying theoretical architecture you simply have to understand. Second, we'll explore the procedural framework, which is the actual step-by-step construction phase of your answer. And third, we are going to finish with evaluation and examiner insights, where we put on our hard hats, act as building inspectors, and look directly at what principal examiners are practically begging students to do in their reports. Before we dive headfirst into Section 1 and establish our core foundation, I need you to do something for me. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get to work on establishing the conceptual framework required to totally dominate these maximum and minimum point problems. Now, this brilliantly illustrates exactly what Cambridge examiners are actually assessing behind the scenes. They map every single question to these 3 distinct cognitive domains. First up, for knowledge and understanding, they expect precise definitions. You must know what a stationary point actually is in reality. Conceptually, when the gradient, or dy dx, equals exactly 0, the curve is completely flat, creating either a peak or a valley. But obviously, at this level, it doesn't stop there. Then comes application. Your knowledge must be totally transferable to unfamiliar contexts. Maybe the question isn't just a standard algebraic curve, maybe they throw a kinematics problem at you, or a really nasty volume optimization question. Finally, analysis. You have to establish causal relationships. This is where we see top students using the Peel framework: point, evidence, explanation, link. You have to prove why a point is a maximum, for instance, providing the evidence that the second derivative is less than 0, and explaining that this means the curve is bending downwards to form a peak. Principal examiner reports clearly highlight that candidates who reference these cross-topic connections and hit all 3 domains achieve significantly higher marks. Let's move smoothly right into Section 2 and see how this all builds into our procedural framework. If Section 1 was our underlying theoretical knowledge, this section is the actual technical methodology. This is the hands-on construction phase of our architectural blueprint. Listen, top students do not just guess their way through a calculus problem. They follow a highly standardized, almost robotic 5-step sequence. Step 1, identify key elements. What is the actual command word? What is the function? And what are the constraints? Step 2, apply relevant principles. Find that first derivative and set it firmly to 0. Step 3, execute analysis with clear working. Solve for x to find the coordinates of your turning points, and then bring in your second derivative test. Step 4, verify results. Does your math actually make logical sense in the real world? And Step 5, present in the appropriate format. Honestly, this brilliant flow is what guarantees a systematically processed answer. Every single time you face a max/min question, you should be mentally ticking off these 5 steps to ensure you're picking up every available mark along the way. Now, let's contrast our 2 types of students. On the left, we have our struggling students, like Alex and Sam we talked about earlier. Their answers are super vague, lacking any context, just random numbers floating in space without any labels. But on the right, that's our distinction level candidate. They provide systematic analysis with strict mathematical conventions. They use proper headings, they use correct terminology, stating crystal clearly, let dy dx equals 0 for stationary points. They use clear annotation. Distinction candidates treat these presentation conventions as an essential professional skill. Rushing through the process and skipping these steps is just a guaranteed way to bleed marks. Stop scrolling, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, now for my absolute favorite part. Let's move into Section 3, Evaluation and Examiner Insights. We've built the solid foundation, we've constructed the procedural framework, and now it is time for the final rigorous inspection phase. We are going to look directly at the raw data and feedback from Cambridge Principal Examiner reports. Get your pens ready because I'm going to rapidly fire off these top 3 insider mistakes, and you need to take notes. Imagine you're looking at a flawed paragraph right now, trying to spot the error. Warning number 1, answers are often too vague. Examiners are practically begging for specific, mathematically rigorous details. Don't just lazily write, it's a max. You need to explicitly write, since d2y over dx squared equals -4, which is less than 0, the point is a maximum. See the difference? Warning number 2, forgetting to check format and presentation. Ask yourself, did the command word ask for the x coordinate only or the full x and y coordinates? You'd be amazed how many top students lose easy marks there. And warning number 3, answers are not specific to the given context. If the optimization problem is about the area of a rectangular farm enclosure, coming up with a negative length literally doesn't make any sense. You must demonstrate evaluative thinking by questioning your own assumptions and justifying your decisions with concrete evidence. And this, my friends, brings us to a massive examiner alert. We need to talk about the method mark strategy. In Cambridge Math, you have to remember that marks are awarded for the process, not just the final destination. Showing your clear working acts as a literal insurance policy for your grade. Let's say you're under pressure and you make a tiny, silly arithmetic error in line 2 of your calculus, but you successfully follow through with a structurally perfect second derivative test using your slightly flawed numbers. Guess what? The method marks can still totally save your score. The process itself holds immense point value. So please, whatever you do, do not just scribble furiously on a calculator and write down a naked final number. Show the examiner the beautiful, logical architecture of your thought process. To absolutely lock in every single one of those method marks, I want you to internalize this 3-part rhythm. Think of it like a speed writing challenge. Number 1, deconstruct the question. Extract the given information, identify the command words, and break it into logical chunks. Number 2, solve systematically. Execute your working with clear, undeniable notation. And number 3, evaluate and check for reasonableness. Like we said earlier, does a maximum area of 2 square centimeters actually make sense for a farm enclosure? Probably not. You might want to check your mouth. This deconstruct, solve, evaluate cycle is the ultimate problem-solving mantra for literally any multi-stage analysis you'll face. So here is a fantastic way to put all of this into practice today. This is an active learning memory hack, and I'm challenging you right now. Create your own personal acronym to memorize these critical analytical steps for distinguishing maximum and minimum points. Maybe it's something like DZSE, derivative, 0, second derivative, evaluate. Whatever works for your unique brain. Inventing your own mental shortcut is genuinely one of the most effective ways to ensure this procedural framework sticks with you all the way into the pressure cooker of the exam hall. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries. But, and this is a big but, only if they practice consistently with our weekly videos. I want to wrap up today's explainer with this slightly provocative thought. If your final numerical calculation is completely wrong, did your analytical blueprint still earn you the distinction? The answer, incredibly and reassuringly, can absolutely be yes, because a true structural masterpiece values the logical, step-by-step process just as much as the final number at the bottom of the page. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.